we're going to dive into a little bit and answer the question, why would I want to be involved with an AI company, and what does zero trust have to do with AI? So first, I'm not going to go too deep into what zero trust is, but let's look at a quick definition, right? So zero trust is a strategy um, designed, a strategy, right? Not a product. It's a strategy to do two things. One is we need to stop data breaches. So this is where this comes in. Data. What is data? You've heard data is the new oil. Why is it the new oil? Well, I live in Texas, so I know that West Texas crude is the benchmark for oil, and there's all kinds of different oil. There's sweet oil and sour oil and shale and all kinds of things. But the other thing, and they have different values, but also data gets and oil both get more valuable as it's refined, right? So if you refine crude oil into gasoline, diesel fuel, aviation fuel, jet fuel, uh, it's the basis of plastics and carbon fiber and nanotubes and all that kind of stuff. It gets more valuable, and it gets more valuable as it's refined into oil gets more valuable that way. Data gets more valuable as it's refined into things that can be used either criminally, right? So if you have a lot of data points, you can do all kinds of cybercrime. You can buy things. You can set up phony identities, or it's for advertising and other purposes, right? So you want to know more and more about advertising, or it's used for surveillance. So data gets refined as well. So we need to stop data breaches. Now, what is a breach? And cybersecurity people get this term confused all the time. We think somebody got into our system, they're poking around, and that's actually the definition of intrusion. Regulators like GDPR in the EU, CCPA in California, PCI for credit cards, they all say a breach occurs when data that is sensitive or regulated is exfiltrated from our networks or systems into the hands of a malicious actor. It's all about stuff going out, not about somebody getting in. And that's what people misunderstand. The thing about a data breach, it's the only thing that IT can do to get the CEO fired. So if there's a data breach that happens, first of all, you allowed it to happen because you had policies in place that allowed it to happen. And second of all, it probably gets the CEO fired, right? So you look at Target was the first time, Equifax, TalkTalk, Ashley Madison, OPM, the big data breach in the US federal government, all that kind of stuff, right? So the strategy does that. It stops data breaches and it makes other cyber attacks unsuccessful. So there's two types of cyber attacks. One is successful and one is unsuccessful. We can never stop a cyber attack from starting because we'd have to be the malicious actor to do that. But we can make them unsuccessful. And we do that by eliminating this idea of trust from digital systems. So I could go on a long rant about trust inside digital systems, but suffice it to say, it's always a bad thing. Trust, this idea that there are trusted and untrusted systems, is the fundamental root cause of all data breaches. So we must eliminate trust. Now, when we look at zero trust, there's a 5-step methodology on how you deploy it. And you can read about this in the NSTAC report. The NSTAC is the President's National Security Telecommunications Advisory Council. I was appointed by the President in 2021 to serve on the subcommittee for zero trust and trusted identity access. And we issued a report in February of 2022 to President Biden. We would consider that to be authoritative on what zero trust is. So you should take a look at that and read more about it. But the main thing we're doing is figuring out what we need to protect. That's called a protect surface. Define the protect surface. And inside of a protect surface, we put in what are known as DAS elements, DAAS. So that stands for data, applications, assets, or services. So sensitive versions of those things. Now, one of the things that happened is this was originally called define your data. So zero trust was created to make our networks and our systems powerful data security enforcement points, right? So it was initially very data centric. Eventually, I realized that ultimately I could protect other things in there. So we take a single DAS element and we put it into a single protect surface, and we build out our zero trust environments one protect surface at a time. And in this way, zero trust becomes incremental. We're doing it one at a time, iterative, one after another, and non-disruptive. The most we can screw up is one protect surface. So it makes it very non-disruptive. And then we have to understand how the system works together as a system. That's called mapping the transaction flows. Within IT networking, there are packets moving around. Packets are zeros and ones represented by electrons and photons, right? And so that's the entirety of our world, really, if you get down to it, if you deconstruct it. So we want to see how that movement happens, especially in the world of data. And then we can architect the zero trust environment to meet the needs of the protect surface. And this is going to become very, very important related to the data stores that are being used inside of AI models. And so, you know, when we think about large language models, what do they need? They need massive amounts of data. And no one is really thinking about how to protect that data. We're worried about, you know, Skynet going self-aware and creating, you know, the robots that take over the world. But certainly the short-term problem is corruption of this data, stealing of this data, lots of things to do with data. So if we understand that each system has to be architected or designed to meet the needs of the protect surface, we can't just have something generic. And then after that, we need to create policy. Everything happens inside of policy. So you have to have a policy in terms of how you enforce everything. And then ultimately, we monitor and maintain this system. And this allows us to take all the telemetry from the system and re-inject it back into the system so we can make it stronger and stronger over time. This is a concept known as anti-fragility. And so there's a book called Anti-Fragile by Taleb, who wrote The Black Swan, and he gave me the vocabulary to talk about what I was trying to do in digital systems, which was make them stronger and stronger as they get stressed out through attacks or more traffic or whatever stressors go on, that we can make it stronger and stronger over time. So that's how we do this journey. Zero trust is always a journey, and it is generally data centric. So when I was at Forrester, I ran two playbooks: network security, architecture, and operations. That was all the stuff related to network security, and ultimately it's where zero trust came out of. But I also ran data security and privacy. And so I want those two things to interact. And so I created years and years ago a thing called the Data Security and Control Framework. I looked at how data works and how we make a simple framework so we can understand it. So the first thing we need to do is define your data. And that was originally, again, the term before protect surface, defining your data. So what do we need to protect, right? So we have to discover it. We have to classify it. We do a really poor job of data classification, by the way. And then we need to dissect it, understand what's going on. Data intelligence and analytics. This is all of the AI, ML, LLM, whatever term you want to call it. That's happening at the dissect level, right? And so now, once we know what's going on, we can defend it. Define, dissect, defend. Easy to remember. So there are only four things you can do to protect data. You can control access to it, right? Which is a lot of identity stuff. You can inspect that access. What's going on inside the packet? Those two things should be done at the same time, even though they're separate functions. And this is what zero trust does. But again, we can also do other things to data. So dispose of the data, right? I advocate getting rid of data that isn't used. So the last research I saw showed 80% of data in a big data environment is what we call stale. It means nobody's looked at it in the last 12 months. No one's accessed it. And so in general, I would advocate getting rid of that data. archiving it off or just deleting it, disposing of it so that it can't be used by malicious actors. We're going to see people really fight back on that because they want to have all the data in the entire world for these large language models. And there's going to be the law of unintended consequences out of that, because there's going to be some massive data breaches, and there's going to be a lot of intellectual property theft, and it's going to be really, really nasty moving forward. And then the fourth thing you can do is kill your data, right? So this is killing it, making it unusable. So the only good data is dead data, in my opinion, from a security standpoint. So you do that through encryption, right? Encrypt as much data as you can. Tokenization, which is an offshoot of encryption, masking that data. And we're not talking about all the data, we're talking about the sensitive data. So things like credit card numbers, PCI, or credit Social Security numbers, credit card numbers, the sensitive things. You're not eliminating all the data, but you do want to get rid of the stuff that really malicious actors can monetize. And you can also mask data, but in some way you need to defend it. And that's what we're talking about today. And why is this important in cybersecurity? Well, let's look at how fast things are moving. I don't know if you've ever seen the movie AlphaGo. If you haven't, you should watch it. It's a very interesting movie, but it's very informative from a cybersecurity perspective. And this gives us a good example of how we think about things. So imagine this is us. We're playing the game Go. This is the game Go right here. I don't know if you've ever played it. It's a very ancient game, very popular in Asia. I got into it through my son. So we get together and play Go. I've never won a game of Go. He always beats me, but that's okay. And so in this game, it looks like this man, Lee Sedol, right here, is playing this man whose name I forget. He's also a great Go player. But this is how we think about our adversaries. It's one human being against another human being. But in fact, all he's doing is looking at the screen and moving the pieces on the board. This is not two people playing against each other. It's one person playing against a computer system. And that's what's happening in our world today in cybersecurity. We are much more manual and think we're fighting individual cyber criminals when in fact they're highly automated, highly orchestrated, and they can do things much faster than we can do, right? So for example, I don't know if you've ever thought about it, but hackers don't have change control. Hackers do not have change control. So they can just constantly come at you, and you're manually trying to figure out, should we make a change here? And we need to automate this process. Now, this is going to be one of the big benefits of AI and machine learning in cybersecurity. I hear a lot of the gloom and doom. Oh, they're going to be able to make more sophisticated attacks more easily. Yeah, maybe so, but we're going to be able to detect and prevent those attacks more easily using automation and orchestration.